Hello, everybody. This is Dr. Zhang for General Physical Science online class. Today, I'm going to talk about the experiment you guys need to do for electric circuit. So this is the simulation website. Looks like. So let's start from the beginning. So there's a couple things I want to explain. First of all, how do you connect a circuit in series? Okay, for example, you want to connect a battery with a light bulb. Okay, you just drag the battery here, and then you drag the light bulb here. Okay, and then you want to drag some wires to make some connection. Just bring the end of the wire to each corresponding end of the light bulb and the battery. Now you need another one. Okay, bring here and here. So when the connection is broken, it's in red, and then when you make them connected, it's in blue. Now you make a circuit in series. Okay, so just like one light bulb, but it's still like in series. Okay, now what if you want to add another thing to your circuit? For example, add another light bulb. What you can do, you can click on this connection point, and then use the scissor to break it. Okay, say you want to bring another light bulb in. Okay, now if you want to, you can bring as many wire as you want to make connections, so that looks maybe easier for you to see. Okay, say you make first one wire connecting the two light bulbs, and then another wire going from the light bulb to this light wire. Okay, okay, so that's again, these two light bulbs are in series. Okay. And I guess this is kind of redundant. If you want, you can take it away, just take this part away. Just use this too. You can see, okay, so what do we mean by connection in series? So what is showing here is the motion of electrons. If you can pick to choose the motion of the current. The current represents the motion of positive charges. So it's opposite to the motion of electrons. So when you have everything connected in series, as you can see from this circuit, there's only one way the current can go. See, there's always going this way, okay? No other way around. So if you break anywhere of the circuit, your circuit is gone. There's no circuit anymore, okay? That's what we mean by connection in series. Now, what about connection in parallel? Okay, so that's the second thing I want to explain. So let me cut this off. So suppose I have these two light bulbs. Okay, I want to connect them in parallel. How do I do it? Okay, uh, first of all, I would make them a little smaller, and then I would connect the first light bulb. Okay, to make it easier to see, I'm going to still use this. Okay. Okay, now I have this one light bulb connected. This is in series. Now, what if I want to add another light bulb? So, to connect them in parallel, you would not break this connection, but you just add another branch to your circuit. Okay, again, you can put many wires to make it easier for you to see. Okay. Okay, so now these two light bulbs are connected in parallel. So what do we mean by in parallel? So as you see here, the current can go two branches. At this point, the current split. One branch going to the first light bulb, the other branch going to the second light bulb. And then they come back together at here. So you have more than one branches. That's what we mean by connection in parallel. So if you break this branch, okay, this branch will still be there, okay? Okay. Anyway, so this is what it looks like, okay, in parallel, okay. Okay, I don't think we need that, okay. And okay, another question, how do we measure voltage or current, okay? To measure voltage of anything is actually pretty simple. So you just bring this voltmeter here. So for whatever you want to measure, say you want to measure voltage of a battery, just bring these two tips to the two side of the battery. Now you see there's a 9 volt. Okay, it's already there. Okay. If you want to measure voltage of two batteries, make them connected like this, and then like two battery connected in series, it'll be like this. Okay. If you want to measure voltage of something in the circuit, that's the same thing. So you won't say you want to measure voltage of this battery, just bring it them here. See, it's 9. You want to measure voltage going on a light bulb, just bring the two tips here. 9, okay. Another light bulb. So you do not change anything about the circuit, just put them in this, put the two tips on the two poles of your whatever device. So what do you want to measure voltage of batteries in parallel, connect in parallel. So to connect them in parallel, just bring the wire like this. This is like put them in parallel. Like the document mentioned, it's kind of like the rungs of a ladder. Okay, so these are two battery connecting parallel. Okay, so let's say I bring another one. This is 3 batteries connecting parallel. Okay, see these 3 batteries are connecting parallel, just like these 2 light bulbs are connecting parallel. So if you want to measure battery voltage battery connecting parallel, you put them here. That's for this battery. Okay, you want to measure for this battery, put them in here. For the top battery, put them in here. Okay. But what do you want to measure the voltage uh, of the 3 batteries connecting parallel, the whole 3? Honestly, there's not much you can do here. Um, it'd be the same thing. Like as you probably noticed, all the batteries are, I mean, the voltage you measure is the same. So you say you want to measure batteries connecting parallel, let's say 1 plus 2. You will still have to put them either here or here. So you will have the same answer, actually. Okay. Now let's talk about measuring current. Okay, for that you need ammeter. Okay, now this is a little different than using the voltage. So let me bring the voltage back. I don't even know actually how to bring it back. Maybe we cannot. I don't know. Okay. Anyway, let's leave it there. So for the current ammeter, so what you need to do is you need to break your circuit. Say, suppose you want to measure the current of this branch that connect to the battery, you first break it here, okay? And then you have to insert your ammeter into this circuit, okay? So you have basically you have to connect your ammeter in series with your whatever you want to measure. So you want to measure the battery current, you just connect them like this. Okay. Now let's say suppose you want to measure the light bulb current. Let's say you want to measure light bulb, the current going through the first light bulb. Okay, you break your circuit here, and then you connect your ammeter here. Okay, see that's your light bulb current for this branch. Okay, again you have to connect your ammeter in series with the device you want to measure. Okay, sorry. Same thing. You want to measure the light bulb of another branch like this one. You break it here. You insert your ammeter here. So this is measuring this one. Okay. This is how you measure. I showed you how to measure the current going through this light bulb, and the battery. Okay. And then other case is the same. Okay. So essentially, when you try to measure current, you have to put this ammeter connection in series with whatever device you want to measure. Well, when you measure voltage, you put this voltmeter in parallel with whatever you want to measure. Okay, like this or this. Okay. I think that's all you need to know uh about this lab. Now, what about the brightness of your light bulbs? Okay, so you can probably see this. Like for example, let's say just keep one battery here. Okay, so if you just have one uh light bulb, yeah, as I said, you can put another wire. Doesn't matter. Okay, yeah, choose conventional. So this is how bright it is. Now, if you break it, you add another light bulb to it. Okay, maybe let's break here. Okay, make connection. Yeah, you can tell by the arrow. I mean, so how the distance of this ray. It actually in this case is actually the light bulb brightness will be smaller. Okay, so you can add another one. Sorry, wait, no. And you connect it to this end to this end, this end. Yeah. Yeah, see, this is even shorter. That means it's a dimmer. Okay. So the Lyra length tells you how bright it is. Another thing, I mean, you see that when you have more of them connecting in series, the total current actually getting smaller. So everything is moving slower. Okay. Okay, I think that's good enough. Okay. It's a very interesting lab, but it could be a little bit confusing. So please watch this video carefully, and I'll see you next one. Thank you.